This is Mech 404 Pictures and Workflows. This is the Lego assembly operation. So for the objective of this project is to design the flow and picturing for the assembly operation of a Lego car using a robotic arm. And this is the final product that we're looking for, and these are the parts that we're getting in this exact state. And the robotic arm is you could just think of one. It isn't it's not as important in this case. And the task, we want to create the documentation, we're going to create documentation, design the flow for this, design the fixturing, build and test the fixturing, and then after all that's done, we want to perform an acceptance test. And deliverables include development plan, process flow chart, technical drawing, pictures of the design, and acceptance test. And the acceptance test is just a video of the operation with using the fixture of the operation, and the fixtures the fixtures being used in the operation. And so the project flow for this is the hardware, i.e. the robotic arm, and then we want to create the documentation, and we want to design the fixture, and along the way document the 8 steps. Then we want to build the fixture and test it, and then we want to test the flow, fixture, and process, and see if they're up to the specifications, as in the one we set. And then if they're not, then we want to come up here and either modify the documentation or modify the fixtures and 8 steps. And then we would want to build it again, and then we want to test it again, and if there's up specifications, then we want to do the acceptance test. This is my fixture right here. Um, as you see, this is called car body, cars, front bumpers, steering wheel, the yellow bricks, the chest, windshield, back bumpers. And then these are the dimensions to build it, and and for the actual Lego parts, you could just look up the CAD files online. And so the 8 steps for this are starting with the car body, or steps 1, 2, 3, and 4, which is input, location, fixture, and constraint. The car body is right here. It is, being and the fixture is locating it, and this is how it's going to come in, and it's also and so the force of gravity is pushing down on it, and the fixture is pushing back up, supporting the car body. Next steps 5, 6, 7, and 8, which are output, release, which would be operation, release, output, and then reset. And then so for this, the car is moved up, and so the robotic arm is overpowers gravity and moves the car body up right here, and then the next is the first pair of tires, leaving off where we left off for the robotic arm up there. We want to right here, this step 1 input, and then steps 2, 3, and 4, which is location, location, fixture, and constraint. And then we want the car is then moved that way and rotated counterclockwise. So then the car is now rotated counterclockwise 90 degrees. So now the car is above the first pair of tires. At step 5, the operation, the car body moves down along with gravity and pushes up against the fixture, and the wheels are attached to the body. And this body is just a mock-up of the actual body. It's not the actual body along with the wheels. So this is just for visualization's sake. So the wheels would actually be attached to the car. Then step 6, 7, and 8, which would be the release, output, and reset. The car body, or the robotic arm, overpowers gravity and moves the car body up, and that's where we end. And then the next pair of tires, starting off where we ended for the first one, the car body is right there. Then we want to rotate the car body 180 degrees for steps 2, 3, and 4, along with moving it that way again. And then step 5, robotic arm goes down and attaches the wheels. Step 6, moves back up, and and that's basically the same thing for on repeat. The first and second steps. The first and this first step and the last step are basically the same. So I'm not going to go over those ones again. So then the car body is moved this way, and the robotic arm rotates the car clockwise 90 degrees, and then the car moves down and inputs it, or yeah, and attaches the front bumpers to the car, goes back up, starting off where we left off. The car body is then rotated this way 90 degrees, or counterclockwise 90 degrees, and then it's moved this way forward, and then it moves down to add the steering wheel, and then moves back up, and then back where we left off. And the car body is then moved this way, and then it's moved, and then yeah, it's moved this way, and then it's moved down to add the brakes and the chest at the same time, and then it's moved back up, and then it's back where we left off. Then it's moved this way, and yeah, it's moved that way, and then it's moved down to add the windshield, and then it's moved back to where it was in this step. And then final step, rear bumpers, where it's going to then leave off where we left off. Then it's going to be rotated one. It's going to be rotated 90. Wait. It's going to be rotated 90 degrees counterclockwise, and then pushed that way above, positioning it above the rear bumpers. Then it's going to move down to attach the rear bumpers. Then it's going to move back up to the final step. And yeah, and then the robotic arm will put the car down somewhere, and put the car down where it's, the designated output, and it would then go back all the way up here, and after receiving the next tray, it'll restart again. And so, some things I would change about this though would be, so right here, as you can see, let me go back here. Right here, as you can see, this is kind of complicated. So I would probably cut down on like the majority of this, since it doesn't really need the majority of this. We could probably work with just this center portion right here. Same with this one. This one's also kind of complicated. I would probably simplify this to make it not easier to be made. So that I would also change that. And besides that, I think it's good. Thank you for watching.